Oh, I don't know about you three, but I have a ton of email to answer.
Really, Eddie? I didn't know you were so popular.
If you must know, I have 2 messages from my mom and about 5,000 offers to buy stock in some company in Uganda. Those emails are urgent!
Well, I'm updating my website. I want to boast about the gift my folks got me for my birthday. 2 tickets to the Inter-Solar Invention Convention.
That's funny. I just logged onto my favorite message board to brag about the new Earth football helmet my mother bought me for having the great grades on my last report card.
What about you, Luria? What are you chatting about over there?
I'm also gloating over a teeny tiny present Daddy just got me.
Really? What is it? A small planet? A dwarf star?
My father just bought me a galaxy. He had it named the Special Luria Galaxy. It has lots of stars in it.
How many?
Let's see. It has 2 0 0 0 0 0 0 0 0 0 0 0 0 0 0 stars.
2 0 0 0 0 0 0 0 0 0 0 0 0 stars?
I didn't know there was such a number.
Me neither. The only problem is every time someone new comes into the chat room, I have to enter that number in again, and I'm scared I'm going to break a fingernail entering all those zeros.
You won't have that problem after we learn scientific notation.
In this lesson, you will be introduced to scientific notation. Scientific notation uses powers of 10 with integer exponents.
Powers of 10? That has something to do with place value, doesn't it?
Why, yes, Eddie. In fact, powers of 10 with integer exponents are place values for the base 10 system. For example, 10 to the 0 power is 1, as in the ones place. 10 to the first power is 10. 10 squared is 100. And 10 cubed is 1,000.
I see a pattern.
Please share.
It looks like the exponent tells us how many zeros are in the product. Is that an accurate deduction?
When working with non-negative powers of 10, your observation is correct.
So 10 to the 4th power would equal 10,000 because there are 4 zeros in 10,000?
Yes.
Wow! How cool is that?
What about negative exponents? Does Zio's pattern work for those too?
Yes, in a way. Remember...
Oh, yeah! Negative exponents indicate fractions or decimals.
10 to the negative first power equals 1/10.
Exactly.
10 to the negative first power is 1 divided by 10, or 1/10. 10 to the negative second power is 1 divided by 100, or 100th.
Oh, I can see where this is going.
Me too. Hey, Eddie, what do you think 10 to the negative third power equals?
1,000th?
You're right.
Each of these numbers is a power with base 10 and an integer exponent.
With each number being 1/10 of the previous number.
You are correct. Each one represents a place value in Earth's decimal place value system.
I noticed something too. 10 to the 0 power is 1 with no zeros.
0 power. 0 zeros.
All of your observations lead us to a handy rule.
To write an integer power of 10 greater than or equal to 1, count the number of zeros in the number. Then use that number as the exponent. Write 10,000 as a power of 10.
Well, 10,000 has 4 zeros. That's 10 to the 4th power.
Look at our powers of 10 less than 1. Does anyone see a pattern?
Sure do. 10 to the negative first power has 1 decimal place. 10 to the negative second power has 2 decimal places. 10 to the negative third power has 3 decimal places.
Can you state the rule?
To write an integer power of 10 that is less than 1, count the number of places after the decimal point. Then, use the opposite of that number as the exponent.
Excellent! Write 1/1,000,000th as a power of 10.
There are 6 places after the decimal point. The opposite of 6 is -6. So, 1/1,000,000th is equal to 10 to the -6th power.
Very good, Zio. Now we know how to convert a number to a power of 10.
Sometimes we will be given a power of 10 and want to find its value in standard form.
Standard form, or standard notation, is the customary way of writing a number.
To evaluate 10 to the nth power for n greater than or equal to 0, write 1 followed by n zeros. Here's an example. 10 to the 5th power is 1 followed by 5 zeros. That's 100,000. To evaluate 10 to the nth power for n less than 0, write 1 in the nth decimal place, preceded by as many zeros as necessary.
What does preceded mean?
Eddie, precede means to go before. Let's evaluate 10 to the -4th power. I'll show you. Write 0 in the ones place followed by a decimal. Put 1 in the 4th decimal place after the decimal. Use 3 zeros to fill the spaces between the decimal point and the 1. 10 to the -4th power is 1/10,000th.
Oh, 1 is in the 4th decimal place and 3 zeros go before the 1. 4 places in all.
In problem 1 of your lesson notes, write 1,000,000 as a power of 10.
There are 6 zeros, so 1,000,000 is 10 to the 6th power.
In problem 2 of your lesson notes, write 1/100,000th as a power of 10.
The 1 is in the 5th decimal place, so the exponent is -5. 10 to the -5th power.
Correct. In problem 3 of your lesson notes, evaluate 10 to the 7th power.
10 to the 7th power is 1 followed by 7 zeros. That's 10,000,000.
You're catching on quickly. In problem 4 of your lesson notes, evaluate 10 to the -7th power.
To evaluate this power of 10, write 1 in the 7th decimal place. Put zeros in the first 6 decimal places. 10 to the -7th power is 1/10,000,000th.
Multiplying by a power of 10 with an integer exponent is a very easy thing to do. Let's have a look. What is 1 2/10 times 10 to the 0 power?
Is this a trick or something? It can't be this easy. 10 to the 0 power equals 1. 1 2/10 times 1 equals 1 2/10 in standard form.
That wasn't a trick. That was a treat.
What is 1 2/10 times 10 to the 1st power?
That's the same as 1 2/10 times 10. To multiply by 10, move the decimal point 1 place to the right. The answer is 12.
What is 1 2/10 times 10 to the 2nd power?
10 to the 2nd power is 100. 100 times 1 2/10 is 120.
And 1 2/10 times 10 to the 3rd power equals 1,200. I get it!
Now what do you get?
To multiply by a power of 10 with an integer exponent, all you have to do is move the decimal point.
Zio, I don't see any decimal points in 12, 120, or 1,200.
Come on, Eddie. The decimal points are at the end of the numbers.
Oh, yeah. Now what's this about moving the decimal point to multiply?
To multiply by a power of 10, you move the decimal point 1 place to the right for every power of 10. When you multiply 1 2/10 by 10 to the 0 power, the product is 1 2/10. The decimal point doesn't move. When you multiply by 10 to the first power, move the decimal point one place to the right. The product is 12. The decimal point moves two places when you multiply by 10 to the second power. And it moves three places when you multiply by 10 to the third power. When we multiplied by powers of 10 before, we moved the decimal point to the right as many places as there were zeros in the power of 10. This time, the power of 10 is written in exponential form.
Wow, that's pretty cool, Zio. Can we use Zio's rule to multiply by powers of 10, Mr. 2?
Only in the cases where it applies. Look at the exponents Zio used. What do you notice about the kinds of numbers they are?
They're all integers.
They're all positive. No, wait. 0 is not positive. They're non-negative.
That's it. Zio has given us a few examples, but what he said is true for all non-negative integer exponents. To multiply by a power of 10 with a non-negative integer exponent, move the decimal point one place to the right for every power of 10. What is 3 52/100 times 10 cubed?
When multiplying by 10 cubed, move the decimal point right 3 places. First, I'll add a 0 to the end of my decimal, so that I have 3 decimal places. The product is 3,520. This is pretty easy. But what happens if the exponents are negative integers?
It's probably the opposite of what we just did, right, Mr. 2?
Let's look at a few cases and then you can tell me.
You're a good teacher, Mr. 2. You always make us think.
Why, thank you, Zio.
Okay, what is 4 7/10 times 10 to the negative first power?
10 to the negative first power is 1/10. 1/10 times 4 7/10 is 47/100.
How about 4 7/10 times 10 to the negative second power?
That would be 4 7/10 times 1/100. That equals 47 thousandths.
What is 4 7/10 times 10 to the negative third power?
4 7/10 times 1,000th equals 47 10,000ths.
It is the opposite. The decimal place moves one place to the left for every negative power of 10.
Great observation, Eddie. Can anyone state a rule for multiplying by a power of 10 with a negative integer exponent? Knowing the rules will help you remember what to do in a problem-solving situation.
To multiply by a power of 10 with a negative integer exponent, move the decimal point one place to the left for every negative power of 10.
Well stated.
Let's put the rule to use. What is the product of 7 92/100 times 10 to the negative second power?
I have to move the decimal point. To the left, 2 places. I add a 0 so I have enough places to move my decimal. My answer is 792 10,000ths.
That's the way to do it.
Mr. 2, this is pretty cool, but when would I ever multiply by a power of 10?
Knowing how to multiply by powers of 10 is useful when working in scientific notation, which we are going to learn about today. This knowledge also reinforces place value because there are powers of 10 in every number.
Are you sure? I don't see any powers of 10 in 25 36/100.
That's because the number is written in standard form. We see the powers of 10 when the number is written in what we call expanded form. To write a number in expanded form, use a place value chart. 25 36/100 equals 2 times 10 to the first power plus 5 times 10 to the 0 power plus 3 times 10 to the negative first power plus 6 times 10 to the negative second power.
I get it. Each digit is multiplied by its place value or its power of 10. And if I take the sum of all the products, I get the number in standard form.
What is 804 and 92 hundredths in expanded form?
I just put the numbers into a place value chart and read from the chart. The number in expanded form is 8 times 10 squared plus 0 times 10 to the first power plus 4 times 10 to the 0 power plus 9 times 10 to the negative first power plus 2 times 10 to the negative second power. Or 800 plus 4 plus 9 tenths plus 2 hundredths.
Excellent! A number is written in expanded form when it is expressed as a sum of products of each digit and its place value. Each place value may be expressed as a power of 10. In problem 5 of your lesson notes, multiply 14 and 25 hundredths times 10 cubed.
To multiply by 10 to the third power, move the decimal point 3 places to the right, adding zeros where needed. I needed to add 1 zero. The product is 14,250.
In problem 6 of your lesson notes, multiply 35 hundredths times 10 to the negative first power.
To multiply by 10 to the negative first power, move the decimal point 1 place to the left. The product is 35 thousandths.
In problem 7 of your lesson notes, write 4 and 75 thousandths in expanded form.
Using a place value chart, I get 4 times 10 to the 0 power plus 0 times 10 to the negative first power plus 7 times 10 to the negative second power plus 5 times 10 to the negative third power.
Good job!
Now that we have the tools to learn scientific notation, that's what we'll do next. And we'll find out if Luria can save her fingernails from typing out all those zeros.
Scientific notation is a way to write numbers that are big or very small, right?
Correct.
Luria could use scientific notation to write numbers when counting the numbers of stars in her galaxy.
Oh, I hope there is a way not to have to use all those zeros.
There is. The number of stars in another galaxy is shown in standard form.
But we still have to write all the zeros.
But there is another way of writing numbers. It is called scientific notation, and it makes reading and calculating with large and small numbers much easier. In scientific notation, the number is 1 and 7 tenths times 10 to the 9th power.
Scientists also use very small numbers, like the width of a hydrogen atom shown here in meters.
In scientific notation, the width of the atom in meters is 1 and 6 hundredths times 10 to the negative 10th power.
Scientific notation helps keep track of place value in very large or very small numbers.
Numbers written in scientific notation are products. The first factor of the product is a number, A, that is greater than or equal to 1 and less than 10. The second factor is a power of 10. 10 is raised to some integer exponent called n.
Large numbers would have positive integer exponents, right?
That's correct.
And small numbers have negative integer exponents.
Very good, Trillian.
Is 1 and 0 tenths times 10 to the 0 power in scientific notation?
The first factor is a decimal that is greater than or equal to 1 and less than 10, and the second factor is an integer power of 10. So, yes, this number is in scientific notation.
Identify which of the numbers shown here are written in scientific notation.
54 times 10 is not in scientific notation because 54 is not less than 10 and there isn't an integer exponent.
6 5/10 times 10 to the fourth power looks good to me. 6.5 is at least 1, but less than 10. And the power of 10 has an integer exponent.
The next one definitely isn't. 425 is not less than 10.
The next one's out too. 32 hundredths is less than 1.
The last one looks good. 5 is at least 1, but less than 10. And the second factor is a power of 10 with an integer exponent.
Only 6 5/10 times 10 to the fourth power and 5 times 10 to the sixth power are written using proper scientific notation. In question 8 of your lesson notes, tell whether the number is written in scientific notation. 5 6/10 times 10 to the seventh power.
Yes, this number is written in scientific notation. 5 6/10 is at least 1, but less than 10. And the second factor is a power of 10 with an integer exponent.
In problem 9 of your lesson notes, tell whether the number is written in scientific notation. 4/10 times 10 to the negative fifth power.
No, this number is not written in scientific notation. The first factor, 4/10, is too small. It should be at least 1.
In problem 10 of your lesson notes, tell whether the number is written in scientific notation. 8 times 10 to the 87th power.
Yes, this is a number in scientific notation. 8 is at least 1, but less than 10. 10 to the 87th power is a power of 10 with an integer exponent.
Now we need to be able to convert between standard and scientific notations. Let's start with converting 1 astronomical unit, or AU. AU is the average distance from Earth to the Sun, and it equals 9 3/10 times 10 to the seventh power miles.
Write this number in standard form.
We convert the number by finding the product. Multiplying by a positive power of 10 is the same as moving the decimal point to the right.
To multiply by 10 to the 7th power, move the decimal point to the right 7 times.
I'll do it! 1. I ran out of space to move.
Aw, come on, Eddie. Mr. 2 told us to add zeros if we need to when moving the decimal point.
Oh, right. 2, 3, 4, 5, 6, 7.
1 astronomical unit is 93 million miles. That's not so far compared to how long it takes to get to my planet.
Let's look at a very small number now. 1 times 10 to the negative 10th power. Let's write this number in standard form.
Convert the number by finding the product. Multiplying by a negative power of 10 is the same as dividing the number by that positive power of 10.
The easy way to accomplish division by a power of 10 is to move the decimal point to the left.
That's right.
Now where's the decimal?
It's always located to the right of a number if it's not written. So, where is it, Edgar Millier?
At the end of the 1?
Go ahead and work it.
Okay. I'll move the decimal point to the left 10 times, adding zeros as needed.
There you go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the left. I had to add 9 zeros.
That is a very teeny number.
It is small indeed. Now let's go from standard form to scientific notation.
The decimal point is after the 0 in the ones place. We move the decimal point between 5 and 4, so there's only one non-zero number before the decimal point.
That's correct.
Now we need to find the power of 10. 1, 2, 3, 4 places to the right to get to the original decimal point. 4 is our exponent. In scientific notation, the number is 5 4/10 times 10 to the 4th power.
Here is another one. The length of an Ebola virus is 2/10,000,000ths of a meter. Write this number that is in standard form in scientific notation.
In a small number like this one, we move the decimal point to the right of the 2.
Then the number will be 2, which is greater than 1 and less than 10.
Now we find the exponent.
Count the number of places we moved from the arrow to the original decimal point.
1, 2, 3, 4, 5, 6, 7.
The number of places we counted is the exponent of 10.
And since we counted to the left of the first non-zero digit, the exponent is negative.
So, the length of an Ebola virus in meters is 2 times 10 to the power -7 meters.
Whoa!
In problem 11 of your lesson notes, write 876,000 in scientific notation.
To write 876,000 in scientific notation, move the decimal point between 8 and 7. Count 5 places to get to the original decimal point. So the exponent for my power of 10 is +5. In scientific notation, the number is 8 76/100ths times 10 to the 5th power.
In problem 12 of your lesson notes, write 6 12/100ths times 10 to the -4th power in standard notation.
Find standard notation by moving the decimal point in 6 12/100ths 4 places to the left. 6 12/100ths times 10 to the -4th power is equal to 612 millionths.
In problem 13 of your lesson notes, write 2400 millionths in scientific notation.
Boy, is this a small number! To write this number using scientific notation, I move the decimal point between 2 and 4. Count how many places I moved left. It's 7 places. So the number is 2 4/10 times 10 to the -7th power.
In problem 14 of your lesson notes, write 4 5/10 times 10 to the -2nd power in standard notation.
All you have to do is move the decimal point in 4 5/10 2 places to the left. The number is 45 thousandths.
We began this lesson by studying powers of 10 with integer exponents.
Powers of 10 with integer exponents are place values. To write a power of 10 that is less than 1, use the opposite of the number of decimal places in the number as the exponent in the power.
To write a power of 10 greater than or equal to 1, use the number of zeros in the number as the exponent in the power.
To multiply by a non-negative power of 10, move the decimal 1 place right for every power of 10.
To multiply by a negative power of 10, move the decimal 1 place left for every negative power of 10. A number is written in expanded form when it is expressed as a sum of products of each digit and its place value. Each place value may be expressed as a power of 10.
A number is written in scientific notation if it is written as the product of a decimal greater than or equal to 1 and less than 10 times an integer power of 10.
To write a number greater than 1 in scientific notation, move the decimal point so that there is exactly one non-zero digit to the left of the decimal point. Count the number of places to the original decimal. Since the count was to the right, use that count as the exponent.
To write a number less than 1 in scientific notation, move the decimal point so that there is exactly one non-zero digit to the left of the decimal point. Count the number of places to the original decimal point. Since the count was to the left, use the opposite of the number of places moved as the power of 10.
To convert a number written in scientific notation to standard form, use the rules for multiplying by integer powers of 10.
My special Luria galaxy has 2 0 0 0 0 0. Wait a minute! To write this number using scientific notation, I move the decimal point between 2 and 0. Then count how many places I move to the right. Um, 15 places to the right. So, 2 quadrillion is equal to 2 times 10 to the 15th power. I wish you guys had shown me how to set the shortcut keys before. I think I busted my 0 key.
In problem 1 of practice set 1, write 1,000 as a power of 10.
1,000 is 1 followed by 3 zeros. It's 10 to the third power.
In problem 2 of practice set 1, write 1/10,000th as a power of 10.
1 is in the fourth decimal place. As a power of 10, 1/10,000th is equal to 10 to the negative fourth power.
In problem 3 of practice set 1, evaluate 10 to the sixth power.
10 to the sixth power is 1 followed by 6 zeros, or 1,000,000.
In problem 4 of practice set 1, evaluate 10 to the negative eighth power.
10 to the negative eighth power has 1 in the eighth decimal place, preceded by 7 zeros. That's 100 millionth.
In problem 1 of practice set 2, multiply 102 and 5/10 times 10 squared.
I added a 0 at the end of the decimal part and moved the decimal point 2 places right. That gives me 10,250.
In problem 2 of practice set 2, multiply 1,087 times 10 to the negative third power.
To multiply by 10 to the negative third power, move the decimal point 3 places left. The product is 1 87,000ths.
In problem 3 of practice set 2, write 9 307,000ths in expanded form.
Using a place value chart, I get 9 times 10 to the 0 power plus 3 times 10 to the negative first power plus 0 times 10 to the negative second power plus 7 times 10 to the negative third power.
Good job! In problem 1 of practice set 3, tell whether 6 times 10 to the fourth power is written in scientific notation.
This number is written in scientific notation. 6 is at least 1 but less than 10, and the second factor is a power of 10 with an integer exponent.
In problem 2 of practice set 3, tell whether 30 times 10 to the fifth power is written in scientific notation.
No, this number is not written in scientific notation. The first factor is not less than 10.
In problem 1 of practice set 4, light travels at a speed of about 300,000 kilometers per second. Write the number 300,000 in scientific notation.
Move the decimal point after the 3. The original decimal point is 5 places right. 300,000 is 3 times 10 to the 5th power.
In problem 2 of practice set 4, the diameter of Saturn is approximately 1 2/10 times 10 to the 5th power kilometers. Write 1 2/10 times 10 to the 5th power in standard notation.
Move the decimal point 5 places to the right. In standard notation, the number is 120,000.
In problem 3 of practice set 4, the diameter of the Sun is approximately 1 4/10 times 10 to the 6th power kilometers. Write 1 4/10 times 10 to the 6th power in standard notation.
Move the decimal point 6 places to the right. The number is 1,400,000.
In problem 4 of practice set 4, the wavelength of red light is shown here. Write this number in scientific notation.
Move the decimal point between 7 and 5, then count left to the old decimal point. Since it's 7 places, the number is 7 5/10 times 10 to the negative 7th power.
In problem 5 of practice set 4, the mass of a dust particle is shown. Write this number in scientific notation.
Move the decimal point between 7 and 5. It is 10 places left to the original decimal point. The number is 7 53/100 times 10 to the negative 10th power.
In problem 6 of practice set 4, the radius of a hydrogen atom is shown. Write this number in standard notation.
Move the decimal point 11 places to the left. Wow, that's tiny!
In question 1 of challenge set 1, Nadia wrote the number 54 times 10 to the 4th power. Explain why the number is not in scientific notation. Then, write the number in scientific notation.
The number is not in scientific notation because 54 is greater than 10. To make the first factor have the proper form, divide it by 10. Then, multiply the second factor by 10 to preserve the value of the expression. In scientific notation, the number is 5 4/10 times 10 to the 5th power.
In question 1 of challenge set 2, Vance wrote the number 32 thousandths times 10 to the negative 3rd power. Explain why the number is not in scientific notation. Then write the number in scientific notation without changing its value.
The number is not in scientific notation because the first factor is less than 1. To make the first factor have the proper form, multiply it by 100. Then, divide the second factor by 100 to preserve the value of the expression. In scientific notation, the number is 3 2/10 times 10 to the negative 5th power.
In question 2 of challenge set 2, write the expression 4 2/10 times 10 to the 3rd power plus 9 1/10 times 10 to the negative 4th power as a number in standard form.
First, write each number in standard notation. The first addend is 4,200. The second addend is 90/100,000ths. The sum is 4,291 hundredths.